Hi, Drew. Thank you so much for joining us.
Hello, thanks for having me once again.
Of course. So hopefully we'll get a few more people on here, but we do have some competition with the nice weather, so we'll see.
Yes.
But just in case, we are recording today's program, so for anyone that cannot attend live, we will have a recording available to our members that we are happy to share with you as well.
Excellent.
Hi, Anne. Hi, Nancy. Hi, Ellen. All right, and I am going to turn off my video and audio, but I will be here if anyone has any questions. Thank you again, Drew.
Yep. Okay, so I'll go ahead and get started. Thank you all for joining us today. I recognize most of you, but I've been here a few times now. But in case anybody does not know who I am, I'm meteorologist Drew Montreuil. I own and run Finger Lakes Weather, which is the region's only independent weather forecasting source for just the Finger Lakes and only the Finger Lakes. I've been doing the daily weather in the Finger Lakes for almost 20 years now. So I have heard a lot of these questions that you guys have submitted to me before, but there were some new ones that I had to do a little digging for. So let me get my slideshow up here. Get my screen shared. Okay, there we go. Okay, so yeah, you guys sent me a bunch of questions ahead of time, so I've gotten some of those and answered them here. There will be some time at the end if you guys have more questions. Before I get started, my setup with my video and audio has changed a little bit, so I just want to make sure everybody can hear me okay. This is the first time I've used this setup in any sort of a live. Okay, so it seems like we are good to go. Okay, so we're going to start off with I kind of grouped these questions into a few categories. So the first category is our unique weather. And one of my favorite questions to answer is why is our region notoriously known to be the hardest to forecast in the country? I don't know if it's quite the hardest, but it's definitely up there. And it all has to do with topography and where we are situated. So here is a picture of the northeastern United States, Finger Lakes, right here in the middle, just to the south and west of Syracuse. So we have lots of different ways the weather can impact us, lots of different sources for storms, moisture. Just there's so many different factors that can go in any given situation. So we can have influences from the Atlantic Ocean, be it cloud cover, moisture, nor'easters in the winter, those big snowstorms. So a lot of influence from the Atlantic Ocean. We can also get influence from the Ohio River Valley, the Mississippi River Valley, all the way down even to the Gulf of Mexico. That moisture and energy gets sucked up to the north in the Appalachian Mountains, which run down through here, kind of act as a buffer and funnel that north right towards our region. So that's another source that we need to look at. Of course, we get those cold northwest winds plenty often coming down from Canada, but I have this arrow colored from cold colors to warm colors because a lot of times the Great Lakes in the cool season have a moderating impact on that. So it's not as cold as it would be if the lakes weren't there. So that's just a whole other layer of complexity. And that's just when we're talking about things on the regional level. As we zoom down into the Finger Lakes itself, this is an elevation map. I know the background's a little hard to see, so I'll point a couple things out. Syracuse is right here. It goes down here. We've got Cayuga Lake Seneca Lake, and then here is kind of the shoreline of Lake Ontario. So the blue and green colors are lower elevations, yellows are kind of a mid elevation, and then the reds are our higher elevations. So you can see very complex terrain across our region. We get everything from these kind of flat plains up in the northern part to all these hills and little river valleys and throughout the southern and middle parts of the Finger Lakes. Um, of course, the Finger Lakes themselves sit in these big valleys, and that has a big influence on the weather. So you have to account for all these little things as you're making a forecast for this region. And oftentimes it's going to be very different in one part to another. And you know, to be able to communicate that takes a lot of practice and knowledge. Um, Here's a little diagram about how the lakes can sometimes influence the temperatures at night. So cold air is more dense than warm air, so it tends to settle down into a valley. However, if you have a body of warm water in that valley, that warm air is going to want to rise, and so you get these little circulations that occur over, you know, just a span of a couple of miles, where valleys that would be cold without a lake are now warmer than they would be otherwise. And it's kind of the mid elevations that are the coldest, and it's very, very complicated. This diagram is actually from my grad school research at Cornell. And what I was doing here is I took a topographic map of a field. This is just a couple of fields south of Geneva and the Fox Run vineyards. So, you know, this is about the size of a field. This is a field. So we're talking a pretty small scale here. And what I did with these topographic maps is I was able to show how the air is flowing and how the cold air is collecting as it flows into these little, you know, we're just talking tiny little dips that, you know, you might notice as you're walking across the field, not that big at all. But it makes these channels, they look like rivers on this map, these channels of cold air. And what my research found was if you stick a tree line in the way of one of these channels of cold air, that cold air is going to bottle up behind it. And that could have big implications for the agriculture. So, you know, when we're talking about forecasting for this region, you know, it's complicated on the very large scale over, you know, the whole northeastern United States and southeastern Canada. It's complicated kind of in the middle range with the lakes and the different terrains, and it's complicated on the very, very small scale where even individual fields can have large differences in temperature and growing conditions. So it really all goes back to those complex topographies and those large bodies of water, whether it's the Atlantic Ocean, the Great Lakes, or the Finger Lakes, all playing a factor in there every day. And you got to kind of sort through all that and know which one's going to have the bigger influences in which situations. So very, very complicated region. That's one of the reasons I started Finger Lakes Weather, is because our weather isn't Rochester or Syracuse. It's definitely not New York City or Atlanta or anywhere else. It's very unique, very complicated, and we really need a local source to capture those complexities. Next question, is it true that in our region, especially Syracuse, the amount of cloudy days equals or surpasses that of Seattle's? Then there was another question of why is Ithaca so cloudy? Now, cloud cover data is hard to come by. There's not a lot of records of it out there. You know, it's not something like temperature and precipitation, which are a lot easier to record and classify and keep detailed records of. So I had a little trouble finding some actual data. What I found suggested that Seattle actually has slightly more cloudy days than Syracuse, but we're talking, you know, maybe 10 more days over the course of a year. That's not really that noticeable. What I did find interesting was the seasonality of the cloud cover. So both in Syracuse and Seattle, winter are the cloudiest times. Here in the Syracuse area, that's because of the Great Lakes. You know, those lakes are warmer than the winter cold air from Canada. And so that creates lift as that warm air wants to rise, and that leads to cloud cover. The lakes are also a great source of moisture that's needed for the clouds. Similar thing happens on the Pacific coast for Seattle, where the relatively warm waters of the Pacific Ocean supply the moisture and warmth necessary for all the clouds. Both Syracuse and Seattle get lots of storms in the winter. It's definitely the stormy season. So both areas are going to be very, very cloudy in the winter. Where it switches a little bit is here in central New York, we're still decently cloudy in the summer. It's definitely not as much as the winter, but there's lots of humidity around that leads to showers and thunderstorms. And getting like a pure, sunny, clear day is still pretty rare, even in the summer months. On the flip side, Seattle gets a lot more of those clear, sunny days in the summertime. It's much drier out there. There tends to be more of an offshore flow of air, so that moisture from the Pacific Ocean is kept out over the ocean, doesn't come inland. They get very few thunderstorms. It's just, completely different sort of climate out there. So our winters are similar. We're cloudier in the summer. So as a whole, if you had to pick a random day, you'd probably be more likely to hit clouds in Syracuse than Seattle, even though technically Seattle has slightly more cloudy days than Syracuse does. Why are we so cloudy? Well, it goes back again to all those sources of moisture that we have nearby, be it the Atlantic Ocean, humidity coming up from the Gulf of Mexico, definitely the Great Lakes, sock us in clouds all winter long. So we just have all these different competing forces that are all trying to throw moisture and cloud cover at us. And that's why we're so cloudy. So this is a very interesting topic as well that I often hear a lot. So a couple people sent similar questions and I abbreviated them here just for the sake of fitting them on a slide. So Ithaca seems fairly safe location as far as avoiding natural disasters. And a lot of people who live in Ithaca have the feeling that many of the most serious localized weather events have tendency to skirt around Ithaca. This is something I hear a lot, especially this time of year when we get into thunderstorm season. And I've noticed this too, both from experience, just living here in the Finger Lakes and watching the radar, that there do seem to be channels of areas that get storms over and over again, while other areas tend to get missed over and over again. I've long wanted to do a study to actually quantify this and get an idea of where this happens. Just yesterday, I sent an email to a company that has lightning data archives. Hopefully I can hear back from them and hopefully it's not too expensive to get my hands on that lightning data because that would be a great way to track how the storms move across the Finger Lakes. So it's something that I've long been pursuing and I'm going to keep pursuing it. As for Ithaca specifically, once again, goes back to the topography. So here we have a zoomed in topographic map. Ithaca's right in the center. You can see Cayuga Lake extending north from there. The reds and white colors are the hills that surround Ithaca. The cooler blues and greens are down near lake level. So especially in winter, it's a very common scenario that the hills will be getting snow. Ithaca might get a mix or rain. Snowfall totals are very difficult to predict around Ithaca. The city being right by the lake in the valley, being kind of a larger city, has a little bit of a heat island effect. So it's, we might get a couple inches in the city in a foot and the hills of Danby or, Brooktondale, those areas. And, that's always something I have to try to figure out, especially with the bigger storms that get hyped up a lot. They tend to be on the warmer side usually. And so it's usually not much of a difference between areas that are seeing heavy snow and areas that might see more of a wet, slushy snow that doesn't accumulate as much. So even, down to the snowflake shapes, sizes, and how much moisture is in them, that's all impacted by these elevations. And that's why down in the city of Ithaca and even, up, Trip Hammer, the surrounding hills, and as you go up the lake, they're not going to see as much snow as those higher elevations down in Newfield, Danby, and such. So, the topography really plays a huge role in kind of determining where the snow is going to be heaviest. I I'm almost certain it plays a factor in where the thunderstorms tend to be the strongest and impact the most. Um, so it definitely has a role, and hopefully someday I'll be able to come and do a presentation and show you exactly how that all works. That's kind of been my goal for many, many years, to get that information quantified and out there. So fingers crossed on that. Okay, our next section is weather and health. This is admittedly a section that I am not much of an expert on. One of my friends at SUNY Oswego, for her senior seminar project, did focus on how the weather impacts health. She had a lot of those impacts that she was feeling. So I had to do a little bit of research on this. This will be a bit of a shorter section, but this is what I was able to find. So the first question is Ithaca a high sinus congestion area, and why? And anybody who has allergies knows the answer to this is yes. It is a very high sinus area, but why is that? So I found 5 main reasons why Ithaca is especially susceptible to seasonal allergies and sinus congestion and all that fun stuff, that some of us are probably starting to feel now. First is those seasonal changes. As the weather changes very rapidly, it's 80 degrees today and it'll be mid 50s tomorrow. That's going to just stir everything up and get in your sinuses and cause all sorts of fun things going on. Once again, the topography. This time, what we're talking about is the valleys can kind of trap some of those allergens in, especially if you get a layer of warm air that kind of sits and prevents the atmosphere from really getting mixed up. That can lead to higher allergens. It's pollen season. It's just starting, so we're gonna have lots of pollen. Also mold. That's the one I get mostly in the fall and towards the early winter. All that leaf mold, all the decaying plants that drives me crazy. And also lots of pressure changes, which leads right into the next question. How does barometric pressure affect the body? Um, Again, this isn't one that I'm too familiar with, but I found 4 ways that pressure impacts the body. The first is the changing pressure. So just as a refresher, pressure is literally the weight of the air pushing down on us. When a low pressure comes, there's less air because all the air is lifting up and out. High pressure, there's more air because it's kind of coming and settling down and in. So those changes in how much pressure there is uh, can change how the connecting tissues between your joints are. Sometimes there's more fluid and more pressure, sometimes there's less fluid and less pressure, and that can lead to aches and pains. In your sinus and ear cavities, and really anywhere there's air pockets, the pressure isn't necessarily going to change at the same rate as it is outside. And so that difference in pressure can cause congestion and pain and your ears popping and things like that. Migraines, um, they aren't, the research that I was looking at isn't really completely sure exactly why migraines kind of go hand in hand with pressure changes. Um, but that's definitely one of the things. And of course, mood and mental health, that's a big thing around here in the winter with the seasonal depression disorder. And that, tied into the fact that in the winter we tend to have lower pressures and more storms and clouds and everything. So definitely has an impact, and I think probably most people fall into one category, another with allergies or aches and pains or everything going on. Okay, so predicting the weather. This is a fun subject. Um, First question is, how does the Farmer's Almanac predict the weather, and how accurate are they? So I went to the source for this. I have my own opinions, but we'll go to the source first. So Farmer's Almanac has a page on their website, How Old Farmer's Almanac Predicts Weather. We predict weather trends and events by comparing solar patterns and historical weather conditions with current solar activity. We employ 3 disciplines to make our long-range predictions: solar science, the study of sunspots and other solar activity; climatology, the study of prevailing weather patterns; and meteorology, the study of the atmosphere. Like all forecasters, we have not yet gained sufficient insight into the mysteries of the universe to predict the weather with total accuracy, though our results are often very close to our traditional claim of 80%. So there's some good things here that the Farmer's Almanac does. And the sun is our number one source of energy by leaps and bounds here on Earth. So it makes sense that the sun is going to have an impact on our weather and climate. And with fluctuations in the energy output of the sun, that's going to have an impact downstream. So I don't really have a problem with that. Of course, climatology, taking that into account, meteorology, that's great. So it all sounds pretty good, but then they try to apply that and make a prediction for a year in these little chunks of like 3 to 5 days, and that just doesn't really work. There was one year that I did buy a copy of the Farmer's Almanac, and I just did a kind of a very basic. I would highlight their forecast, and it was either going to be green if yeah, it was a good forecast, yellow if it's like it's kind of okay, and red if it was like completely wrong. And there were very few green highlightings that year, and an awful lot of red. So that was a number of years ago and very unscientific and just kind of anecdotal, but I don't know about that claim of 80% accuracy. That seems a bit too high for me, a lot too high. But if they have data to back that up, then I would be happy to see that and see how it goes. But I don't put a whole lot of stock in the old Farmer's Almanac, just from experience and knowing how well we can predict the weather, even 10 days out, let alone 300 days out. Okay, this is the big question. There are several models that are used to predict weather event. Can you describe the difference in reliability of each? Okay, so one of the websites, this is just one of the websites that I subscribe to that has weather model data, gives me all of these options for different weather models that I can look at for different things. Some of them are more specialized, like there's the tropical models at the very end there. But a lot of these, the first two columns, especially the short-term forecasts and the global deterministic models, that's all, stuff that meteorologists are using just for their day-to-day forecast. So there's lots of different types of models in here that I have access to. Some of them run as frequently as every hour. Some of them will only run once or twice a day. And then within each of those models, there are tons of options to look at. So this is a screenshot of what it looks like when I go to access the European model. The European model is run by the European Union, and it is generally the best model out there for large and medium scale phenomenon. So getting a good picture of what the weather is going to be doing. This is my go-to model. This is about the only model that I tend to look at for anything beyond 3 days. The kind of American equivalent is the GFS model, and that's what you'll see a lot of people on social media and TV showing. And I barely ever look at that. I probably look at it maybe about 10 times a year. And that's only when things are really complicated. I just want to see if maybe there's something else out there that I'm missing. And usually I don't look at it very long. So the European's kind of my go-to model for the big picture things. Lots of different options to look at within the European. And then you get the European model ensembles. So they take the model, they change the equations and the physics in the model a little bit and run it again, and they do that 50 times. So there's 51 different versions of the European that I can look at a time. So this was yesterday morning, I grabbed the European ensembles for the high temperatures over the next 15 days or so. So there are well over 1,000 data points here in this one graphic that I'm looking at. So how this graphic works is time is going this way. So this is today right here. And each, if we take just one column, that's one time. So this is probably kind of circling, and I got a bad color to do it because it's warm. That's probably the 2 p.m. forecast. And so we got 50 different possible temperatures, 50 different model projections for the temperature at 2 p.m. in Ithaca. And so when I'm looking at this sort of a graphic, I'm not looking at the individual little boxes. What I'm looking for is, are things similar? Do we have a small range of possibilities? So you can see in this area that I kind of circled, everything is pretty much the same color. It's that dark orange, maybe a little bit of light red. So that means everything's pretty close together. So there's pretty good confidence that it's going to be up around 80 today, and it's 82 right now. So that is one bias that I know of in the springtime with the European model. It tends to be too cool on these warm, sunny-ish days. So European was saying upper 70s, I went low 80s. As you go further out, the range of possibilities gets greater and greater. So the confidence in whatever's going to go on is less and less. So really, I'm just kind of looking at overall patterns here towards the weekend. It's cool. And then we see kind of an upward trend. So in my blog post this morning, I said that, next week, it looks like it's going to gradually get warmer, but there's a lot of uncertainty. These boxes in here kind of show what the range of most possible things are. So, anywhere from 60 to 75, it's a pretty good range, but then you get the outliers that could be even greater. So tons of data to look at there. Another way to look at it is how the model is changing over time. That's what this one does. So each row going across is a model run. This was the model run from Tuesday night, Tuesday morning, and so on and so forth. Last Tuesday night, Tuesday morning, and so on and so forth up through yesterday morning. And then a column going down again is a single time, so you can see how the model is changing over time. If the colors are getting brighter and more blue, that means in this case, the models are trending towards more and more rain. If they're going from green to gray, that means they're going more towards less rain. So lots of things to look at. I wanted to do a little study as I was putting this together. So these are model images I took yesterday late morning, so a little over 24 hours ago. And I took several different models and plotted the same thing. And this is for 2 p.m. today, so pretty much right now, what the radar should look like. This is the European model, wasn't really showing anything. The GFS model that I don't usually look at, so this counts as one of my 10 times this year, showing a couple of scattered showers basically across the area. The NAM 3-kilometer model, this is one that I like for thunderstorm forecasting and for lake effect snow. It runs 4 times a day, but we get forecasts every hour out to about 36 hours, I think, 36, 40, somewhere in there. So it runs about a day and a half to 2.5 days out. So it wasn't showing very much either. This is kind of a newer, I don't know if it's still technically experimental model, was showing a line of thunderstorms going through the northern Finger Lakes. And the high-res rapid refresh, which is the model that runs every hour. It is actually very good for thunderstorm forecasting in the near term. 24 to 36 hours out, it was showing a big line of thunderstorms. The radar is almost perfectly clear right now. So these last 2 models have the timing wrong, but the idea is right for later today. And now these models are showing a more intense line of thunderstorms at the proper time later in the afternoon. So you really, it takes so much effort and time and knowledge and experience to sort through all this different data and know what models are good in what situations. And, even if the model has the time wrong, it might have the idea right, or it might have, the timing right, but the idea wrong. And it just takes so much experience to get through that. And that's why, I see all the time on social media, other meteorologists posting an image like this. So they'll give you this image and call it their forecast. And, as you just saw, that's just a tiny, tiny fraction of the data out there that needs to be considered when making a forecast. You can't just fire up one computer model and call it good. You have to constantly, even if you just want to use one model, you have to watch it over time and see how things are changing. So models are a great tool, but you have to know how to use them properly. And unfortunately, a lot of meteorologists out there don't know how to use them properly. So future concerns. Here is a very relevant topic for today. We got a severe weather event coming later tonight. How likely and how soon will we see more frequent tornado activity? So I talked a lot about the tornado season we had last year in January when I did a talk with you guys. I think it was January. And trying to put that record-breaking year into some sort of good context. So here's a slide that I borrowed and slightly modified from that presentation. The first point I want to make is actually the last one on the slide here, is that tornado records in our area and across the country really began in 1950, but they are not very good, and tornadoes are very difficult to record and get into the archives prior to the current radar network going up in the late 80s. They couldn't see the tornadoes and the storms in anywhere close to the same manner that we can now. And the radar network has been upgraded since then with even better equipment and technology to detect tornadoes. And so there has been a huge increase in the number of detected tornadoes. But how much of that is actually an increase in tornadoes and how much is it the increased radar capabilities, the visibility of the National Weather Service and people knowing that if they get damaged, that they call the National Weather Service. Smartphone technology, everybody's got a camera in their pocket. It's so much easier to get not only instant information from the meteorologist to the public, but from the public to the meteorologist. Back before camera, the cell phones, if you had damage, you'd have to take a picture and go to the store and get it developed and then send it to the National Weather Service. That would take at least a day for the mail to get it from one spot to another. Now it's instant. People are, storm chasers are out there live streaming tornadoes, in the Great Plains and giving the Weather Service instant access to that information that, yes, there's a tornado on the ground. I see it right there from the storm chaser's camera. So, all these factors are leading to tornadoes being so much easier to identify and find. And trying to sort through that noise to see what sort of an increase there is and how much it is, it's really impossible. For here in New York State, last year was our 4th year on record with more than 20 tornadoes across the state. The other years were 2011 and then 1992 and 1993. We're talking 30, 40 years worth of even somewhat reliable data, and that's definitely not long enough when we're talking meteorology to identify any sorts of trends or anything. So it's really a mystery. The media loves a good hype story and a good scare story, but how the tornado picture, especially in an area like ours where they're not as common, is changing is really just, there's not nearly enough data for a long enough amount of time to really understand and grasp that yet. But that, like I said, in several of the talks I've given here, that, tornadoes in New York, one of my main interests of research in our area. So it's definitely something that I'm going to keep digging into and keep analyzing year after year. Should we be concerned about more frequent and longer droughts? This was a very interesting question and one that I didn't have a good answer for at first, so I had to go do some digging. One thing I did know is that, kind of like tornadoes, drought classification records don't go back very far. The U.S. Drought Monitor is the main spot that is keeping track of drought conditions across the United States. This is the current drought map. We've actually been holding on to this little area of, they call it level 0. I think it should be level 1. Just this little area of almost drought conditions. going back to last summer. It just hasn't really changed a whole lot. Um, so we are kind of borderline drought. If we end up having, a couple of stretches of dry weather these next couple months, we could easily slip into drought conditions. On the flip side, if it's rainy, well, that'll get erased and droughts won't be on anybody's mind. But you can see, they are classifying droughts across the country. They do an update every week. And the unfortunate part is that they've only been doing this since about 2000. So here is what the droughts have looked like since 2000 for Tompkins County. Of course, 2016, that was the big severe drought that we had that, nobody in recent memory could really remember. Far and away the most significant drought we've had in the last 25 years. But you can see, it's kind of an alternating period of it gets dry, it gets wet, it gets dry, it gets wet, and kind of goes back and forth. Most of the droughts aren't too bad. Sometimes we get, into the second classification. It looks like that happened in 2020, a little bit in 2022, 2012, briefly in 2011, before that turned into flooding very, very quickly. Those big floods in the southern tier in 2011. Not much drought at all from about 2016 up into 2011, and then a couple in the early 2000s. But again, as far as trends, the drought monitor isn't going to help us figure this out. But I wanted to go deeper. So what I did is I took the monthly precipitation in Ithaca every month going back to the 1800s. So there were over 1,500 months. I took the 52, I did 52 because there was a tie between 50, 51, and 52. The 52 driest months and the 52 wettest months. And then I grouped them in by decade and wanted to see what would happen. So here is the results of that. Going back to the 1890s all the way up through the 2020s, keeping in mind we're only halfway done with the 2020s. So it's, this is kind of a little bit of an asterisk here. Got it. It's worth looking at, but you can't put too much stock into it yet because we're only halfway done. So yeah, I grouped how many months were in that. It's like the top 3% driest and top 3% wettest months. So, the 1890s had 2 of that top 3% driest months and 1 of the wettest months. So for a total, they had 3 what I called extreme months, either wet or dry. So the black bars show how many total wet and dry months there were each decade. The yellow bars are the dry ones, the green ones are the wet ones. And you can see that a couple things stick out. First of all, there's this big kind of lull in extreme weather in the 50s, 60s, and 70s as far as precipitation goes. There were a lot of big snowstorms during that time. But as a whole, there weren't a lot of extreme months in that time period. 1910 through 1930s, quite a lot going on. 2000s have had their share. Down here, I plotted trend lines and put an R-squared value. What the R-squared value is, it's a statistical analysis that says how much of the variability is coming from that particular factor, in this case, the time. So as time passes, how much of this variability is due to the time. So for the dry months, these decimals can be converted to percents just by moving the decimal spot 2 spots. So that's 0.6% of the variability of the dry months is due to time. So basically, there's not really any correlation at all between these dry months and time going on. So to get back to the original question, do we need to worry about more frequent, longer droughts? Based on this, it doesn't look like it. It doesn't look like there's really any correlation. This is a very basic study, but on that front value, it doesn't look like there's very much correlation. However, if you look at the wet times, it's about a 5% correlation. It's still not very high, but like that's noticeable. It's a whole order of magnitude greater than that. And you can see, especially here from 1960 through the 2010s, there's a nice straight trend line going up right there. So, maybe there's something there, there's a nice dip here, and then it's kind of wobbly in the early part of the record. So what's actually going on there? That would be a good spot for further research. And, as we go for the next couple decades to see if this sort of pattern continues or if it reverses itself, um, that'll be something interesting to watch out for. Um, you know, there's lots of factors. I don't usually talk about climate change and everything because, everybody has their opinion. It's so polarized and political and everything. Um, the one thing I do caution people about is just, it's the same thing with the day-to-day weather. The media loves to hype stuff and create a good scare story. So you do have to be a little bit careful with some of that stuff and go back and actually look at the data. Things are changing in the climate. Um, what those causes are is not something that I study as, just a meteorologist focused on the next 5 to 7 days. But I know people are very interested in that and very concerned about that. So sometimes it's worthwhile to go back and look at the data and see what's going on. And just because this is the data for Ithaca doesn't mean the data for Rochester is going to look the same or the data for Nashville, Tennessee is going to look the same. There's always so much variability all throughout there. That you also have to consider. So there's not one straight answer to a lot of these questions, and that's why the Weather Service and NOAA need funding and research grants to solve these problems and questions. Okay, so that is what I've got for your questions. If anybody else has any questions, see there is one comment in the chat here. And yeah, it's going right back to what I was saying, about the current state of things. So Mary Helen says, if the European model is the one you find the most reliable, will we develop forecast problems should Trump purge the NWS? Yes, absolutely. The European model is one of the most reliable. Yes. It's, really good for those big picture things. The problem is you have to pay to access it, as opposed to the American models, which are freely available to the public. You could go look at the GFS right now if you wanted, if you know where to go find it. I have to pay a subscription to a company that pays a subscription to access the European data. And it's not the best model for all things. When we're talking about these global models, they're not going to be able to get down small enough to resolve thunderstorms like some of those other models I was showing you. And those are the models that I've been looking at all day today, not the European model. And a lot of those are developed on grant money, either through the Weather Service or universities or other, scientific organizations. And, there's, especially with machine learning and AI coming on board now, there's just, it's kind of an explosion of research that needs to be done in these areas. And if the funding isn't there, we're not gonna be able to do it. And we're not gonna be able to catch up to the European, that's for sure. Just because the European's ahead now doesn't mean it always has to be. We could, if we invested in it like the European Union invests in their models, then maybe the GFS would become the best model in the world instead of the European. But it doesn't look like that's going to be happening anytime soon. And I'll also say the Weather Service, they provide so many other things besides just computer model access. The Storm Prediction Center, the National Hurricane Center, they are absolutely vital organizations that save countless lives every year with their forecasts and outlooks. Severe thunderstorm warnings, tornado warnings, they're coming from, our local Weather Service office. For us, it's in Binghamton. Like I was saying at the early part of this presentation, you need people with local knowledge to be able to forecast in a lot of these areas of the country that have these unique things going on. Especially here where we've got so many unique factors. All those funding cuts, they're not going to help anything. They're going to make it worse, and we're going to get further behind. Okay, John, I see you've got your hand up.
Yeah, given the fact that we rarely have earthquakes and they're very minor, and the flooding is unusual. Forest fires, big ones are certainly rare. Small ones are possible.
Yep.
Earthquakes. So major disasters tend to miss us. Should we be advertising Ithaca as the place for people to move to?
Yes. I mean, we really are very blessed where we are because, we don't have the earthquakes or the wildfires like LA has. We don't have the big monster tornadoes that take out whole towns, in the Midwest. We don't have the hurricanes that, are just so destructive when we're such a huge area. We get the seasonal depression disorder from all the clouds in the winter, and we get our fair share of snow, but even compared to the northern plains where they get wind chills of -50, -60 degrees every winter, it's not too bad here. My wife's from Minnesota, so she got to experience that. And
Well,
the first time she came out here, it was like 20. It was like it's a heat wave for her. We're all over here saying it's so cold. So pretty darn good area. I'll take it.
so, see, am I on mute?
Nope, I can hear you.
So I think it was about 2 days ago, there was a very alarming forecast. It showed a line of very heavy storms going from like the Tennessee Valley up, going in a northeasterly direction. It's a very thin line, red.
Yep.
They said you beware of tornadoes, and they actually mentioned Rochester, Syracuse, Plattsburgh, and the way that the line was advancing. A few of us around here got a bit worried about these tornadoes, but turned out it was probably absolutely nothing. Is that is it that they? I'm wondering if they just want to up their viewership that to have these alarming sort of forecasts. I don't know if you
Yeah, it's
know that
it's a
about
fine, it's a very fine balance sometimes. And severe weather forecasting in particular is something that I'm always trying to figure out what is the best way to do it and what is the best balance between getting the information out there and not scaring everybody, because even in a big severe weather event, most people are still not going to have a tree fall on their house or see a tornado. But so it's a really big balance. So two other important points about that is that yes, it does still look like there is going to be a line of severe thunderstorms tonight. The Storm Prediction Center, literally, I just saw it pop up, has a discussion out, and they are saying that there's a 60% chance that a watch of some sort, probably severe thunderstorm watch, will be issued in the next 1 to 2 hours. So, it's that balancing act between hyping it up and getting the word out there and doing that in a most useful way. And I have some new ideas that I want to experiment with this season to try to get a little bit of a better way to do that. We'll see if it works. I know people in the Midwest yesterday, they had, lots of very strongly worded warnings about the severe weather potential out there yesterday. And, like I said, my wife's from Minnesota, so we have a lot of relatives out there still. And so I was, sending them updates over the weekend about the potential for this. And as a whole, it didn't really pan out. There weren't big, long, destructive tornadoes, which is a good thing. But the potential was there, and it's a very fine line between a non-event and a big blockbuster event. And so it's all in communicating the uncertainty. And that's something that I've long tried to do. When there's a snowstorm coming, and it's going to be a difference of 20 miles, whether you get a foot or an inch of sleet and rain mix. I let people know that, and I say, I circle the area on the map and say, anything goes in this area. So be ready for this, but it could be this as well. Now, the other thing, when it comes to severe thunderstorms, this is something that really caught a hold of me last year. We had a lot of tornadoes in New York last year, more than we've ever recorded. And you know, one or two of those were particularly strong, and there were, I think there was at least one fatality from a tornado in New York last year. So tornadoes are an important thing. Like I said, they're one of my top research interests. You know, I love to dive into tornado data, try to, you know, see where the patterns are and you know, compare, you know, try to bring awareness to the fact that these do happen here. All that being said, severe thunderstorm winds are often just as destructive as the tornado winds we get around here. You know, it's very rare for us to get tornadoes over 120-mile-an-hour wind speeds. You know, that's not the case out in Kansas and Texas and Alabama, you know, those places. Here, most of our tornadoes are weak, 90, 100-mile-an-hour wind speeds. Our strong thunderstorms with a microburst are also producing 90 to 100-mile-an-hour winds. They're doing just as much damage as a tornado, only they're impacting a much bigger area. And so one of the things that really caught me last year is, you know, the media is talking about all these tornadoes, but we had similar storms in nearby areas that were causing much more damage over a bigger area, but the winds were going straight, not spinning in a circle. So nobody paid attention to that. So that's, you know, tornado is the buzzword that catches everybody's attention. And, you know, I mentioned that in my forecast today because there is a small chance of a tornado or two. I could see it happening. I expect there will probably be a tornado warning somewhere today. But the severe thunderstorm winds are a much bigger concern today than any tornadoes would be, because they're going to impact a lot more people than a tornado would. So
Drew,
it's, yeah.
I can't raise my hand on my device because I can't find the icon. But you know, I used to live in the Midwest, and you know, tornadoes. You know, the in the Midwest, which are clearly more severe, there was the warning. You know, the sky turns green. You hear, like, you think a train is coming.
Yeah.
Is that also true of the milder tornadoes that we might experience here, or are those, you know, super storms?
So I'll do the train sound first. So the train sound comes from the strong winds, and I have heard similar sounds here, from, again, those straight line winds. So I mean, when you get 90-mile-an-hour winds, you can hear that coming, you know, whether it's going straight or spinning in a circle. The green sky is kind of a common misconception that green sky equals tornado potential. What is happening with the green sky usually is that there's a lot of moisture up in these clouds, and storms tend to happen most late in the afternoon when the sun is at a lower angle. And so the light coming through those clouds and interacting with all those raindrops gives it that green hue. So you could have, you know, a green cloud that's just a bunch of rain and not even any thunder and lightning necessarily. And you know, what angle the light's coming in the cloud isn't really going to have any impact on how the winds are coming out of that cloud. So the green sky isn't really a good indicator of a tornado, but if you hear that train sound, whether the winds are coming straight at you or spinning towards you, you're going to want to get inside and away from your windows. So we can definitely have that here.
Also, to follow up, they used to say that if you could open a couple of windows a little bit in your house, you might have less damage. Is that true? I mean, it's obviously a pressure question, but
yeah, I've seen mixed research on that. I think that generally it's not going to have much of an impact. A lot of the damage, I would say probably the majority of the damage from a tornado is coming from the tornado throwing things at your house like missiles from your neighbor's house. And so, you know, whether your window's open or not, if you're going to chuck a 2x4 at it at 100 miles an hour, it's going to do some damage. So, you know, yeah, it's kind of a mixed bag on the research, whether that really helps. I can definitely see the theory behind it. because, you know, a tornado is just like a super condensed, very low pressure system. The pressures inside the tornado are very, 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 very low, which is why there's such strong winds, because it's when you have low pressure, the air is going to rise and it just acts like a vacuum cleaner, and it's sucking all that air into the circulation really fast. So, you know, there might be some sort of, you know, trying to equalize the pressure, you know, kind of like with the sinus question in our eardrums. You know, the pressure difference that causes some people to get, you know, ear discomfort, popping sensation. So, yeah, it's definitely not something that has been researched around here very much, I'm sure, because we don't get the tornadoes like they do. But I would say the jury's not completely settled on that one yet.
And final question, because I don't want to monopolize, but the town that I lived in Iowa was in a bend of a river, and everyone said, "Oh, you don't have to worry because we're in the bend of a river." And I always thought that was BS, but I don't know if you want to comment on that.
Yeah, it is.
Geography.
Yeah, the tornadoes don't care about rivers at all. They don't even really care that much about mountains. There is a case, I don't remember what it was, of a very strong F4 tornado at about 10,000 feet elevation in Yellowstone Park or nearby there. So, you know, I won't say that topography doesn't have any impact on the path of a tornado. I know some of the tornadoes we get around here do kind of tend to skip along the hilltops in some ways. And so it's actually the hilltops that are getting them, and not necessarily right down in the valley. It might kind of skip over that. But generally speaking, you know, tornadoes can happen anywhere, and, you know, definitely a body of water isn't going to stop them. I've seen many cases where it's just gone right over like it's the, you know, hard ground. Not really any impact at all. And you've got your hand raised.
Yeah, I have two totally unrelated questions. When you were talking about pressure and sinuses and stuffy headedness, what did you say? Whoops, I think I froze.
Yeah, I was saying that there are several different influences that could be resulting in that. When we're talking about pressure changes, the air inside our sinus cavities isn't necessarily going to change pressure at the same rate as the air in the atmosphere outside. And so you're getting this pressure difference, and that can cause things to flare up and be uncomfortable.
Was it high pressure that's more apt to cause stuffiness, or?
I think it's more the changing of pressure. So either going from high to low or low to high, kind of in a quick succession, as opposed to it necessarily being high or low. I think it's that changing from the research that I was able to see.
So people who say they're they feel more joint pain, for instance, it doesn't matter whether it's a low pressure coming or a high pressure coming, it's the change of the pressure?
I would say that across the population as a whole, it probably doesn't matter. On an individual basis, there's probably some people that feel it more with a low pressure and some people that feel it more with a high pressure. It probably, you know, just depends on the way the body is structured and the microfibers and all that. You know, it's definitely not an area that I am too familiar with.
Yeah.
So, you know, that might be something that I could do some more research on for sure.
And the other question I have is current. I have a daughter picking up her son in Ohio, driving to Ithaca.
Mm-hmm.
Do you know what's happening on the way? She's coming from Columbus.
Well, Columbus right now.
I think she's probably most of the way here by now.
Yeah, she should be fine. Then Columbus is getting severe thunderstorms right now as we speak. But between here and there, there isn't really much of anything, so as
Oh,
long as I'm expecting things to start popping up in the next 1 to 2 hours over Western New York, and then getting in here kind of later afternoon, early evening. So as long as she's back before that, she shouldn't have any problems.
not sure that'll happen, but we'll find out when
Yep.
she gets here. Thank you, Drew. This has
Anytime.
been very interesting.
Well, you're most welcome. Alan, go ahead.
I wanted to thank you for these many explanations. I especially appreciated those close-in Ithaca elevation maps as part of the explanation for why there might be skipping phenomena and things of that sort around here. I'd all wondered about that, and the way you explained it seemed very clear and
Great.
just
Thank
great.
you.
So are many other things, but thank you.
You're most welcome. Yeah, when you get to look at the elevation map like that around Ithaca, it's crazy. How many little things are going on there. Okay, any last questions?
How often are you willing to do programs for us? Because everybody loves them and we don't want to take advantage, although we really do.
Yeah, I mean, I kind of run through my course of talks that I have pre-made now. So I'll need some ideas for new talks to make up. But as you could probably tell by now, I like talking about the weather a little bit. So
Well, I've been joking that Ann Levitich is our weather girl. I told her to bleach her hair blonde and, start. But so you don't mind if Ann is in touch
yeah,
again?
no, but yeah, I like to do this. So
Well, we like it.
yeah.
Thank you.
Yeah, we got to try to not schedule them 3 months in advance for severe weather days. 'Cause that happened to me last year on the first big tornado day. I had like 4 months ahead of time scheduled to talk with a bunch of high schoolers in a summer earth science program at Cornell. And like literally the talk was exactly lined up with the start of this event. And I got on and I said, guys, I don't actually have a talk planned today because we got some really crazy weather coming on. And then it just started popping tornado warnings left and right. I was like, I don't even know what to do. They got to see the raw emotion and everything. And I guess they loved it. I hardly paying attention to them.
So Drew, I actually did have one more question, but I didn't want to monopolize earlier, but now I
Go for it.
So, you see these warnings come up, and they say severe thunderstorm warning, okay, or no, watch, or possible, severe thunderstorm.
Yep.
But other warnings are very specific. It's tornado watch and tornado warning and high winds. So if you don't have those very specific things in, if it just says severe thunderstorms, what does that mean? Because if it was tornado, they would say tornado. And if it was high winds, they say high winds, and they say hail and all that other stuff.
Yep. So there are 2 possible ways to meet a severe thunderstorm criteria. One is winds of at least 58 miles an hour. And 58 is a really random number. It's because they developed the warning in the kind of the scientific standard units, which is knots. So that's 50 knots. I think it's 50 knots. Don't quote me on that. But when you translate it over to our English miles per hour, it's 58 miles an hour. So basically 60-mile-an-hour winds are greater. We'll classify things as a severe thunderstorm. The other way is hail. It used to be 3/4 of an inch. About 15 years ago, they increased that to 1 inch. They found that 3/4 inch hail generally doesn't do enough damage to be classified as severe. So if you get a severe thunderstorm warning around here, usually it's going to be driven by the possibility of high wind speeds over 60 miles an hour, but it could be hail as well. Why they don't break those into 2 separate things is because a lot of severe thunderstorms end up having both. And it's also very hard to necessarily tell which one of those is going to be coming out during the severe thunderstorm. So they kind of lump those two factors in together. Tornado warnings means there's a tornado. All the other ones, like you said, are kind of more specific. The one that's the least specific is a winter weather advisory. That can be issued for anything from accumulating snow to ice to blowing snow to freezing fog. It's kind of a mess. And the Weather Service, for the past few years, it keeps getting delayed, has been working on a program to simplify their alert system. They will eventually be getting rid of advisories altogether, so there will be no more wind advisories or heat advisories or those pesky winter weather advisories. It'll just be watches and warnings. I don't know when that change is happening at this point. It was supposed to happen a couple of years ago and it hasn't yet. So that's kind of the way they do things with that. But yeah, all those come from the National Weather Service.
Mhm.
Yeah. You're welcome.
Thank you.
Mhm.
And thank you again. It's
Yes.
always very interesting.
Yeah, you are most welcome. So I will just quick mention that I will be doing a live blog on the website, probably starting in a couple of hours, tracking the severe weather tonight. So if you see the sky starting to get dark and hear those rumbles of thunder, you can just hop on flxweather.com and get the latest up to the second information. And you can ask me questions there too. I won't be on video, but I'll be there glued to my screen. So
Thank you, Drew.
you most welcome. Thank you all for coming and sacrificing this very nice afternoon to come listen to me talk. So
Yeah.
take care, everybody.
Thank you. And Drew, I can tell you there's a lot of rain coming because I just painted my deck yesterday.
Oh, it's your fault then.
I know.
Now my plants need it, so I planted a bunch of trees this spring, so I need the rain.
Yeah, nice. Well,
Bye, everybody. Thank
Bye.
you.
Thank
Take
you.
care.